Hello children, good evening everyone. Keep your videos on.
Good evening, ma'am.
Who is Usha? New name.
Ma'am, I'm Daksha.
Oh, okay. Can you just rename yourself, children, everyone, if you have logged in with a different name?
Ma'am, I'm not able to rename actually.
Okay. Next time, just if you have logged in with a different name, please let me know, children. I should not be in a confusion. Who is this new person? And Smriti?
Yes, ma'am.
Oh, okay. You're Smriti. You got confused. Sorry. Shreya? Shreya, keep your video on. Shreya? Okay, everyone, audio should be on. Because we are not going to, I'm not going to teach you anything. We are going to have a discussion. It's not like teaching and learning. Okay? We only discussion. Daksha, your audio should be on. Now, so today we are going to start the lesson, the first chapter, that is in physics, the first chapter will be light reflection and refraction. So we have studied about what do you mean in the bridge course. When I was teaching, I taught you what do you mean by reflection, what is refraction, correct? We saw the difference, right? What is reflection? Reflection means, where do you see the reflection? Simple thing. What is reflection and refraction? If I have to tell you, you take a ball, throw it on a wall. on a solid wall, what happens?
It reflects back to us.
It bounces back to you. It doesn't reflect.
Like, yeah.
Yeah. We don't call it reflection. We say when it is a ball, we say it is bouncing back to us. Correct? So the same word can be used when you have to define reflection. We will just say bouncing back of the light to the same medium is called reflection. Okay? If you throw the same ball into a heap of sand, what will happen? Will it bounce back to you or it will go inside?
It won't bounce to us.
It won't move.
To some extent, you can say it will go inside, correct? Or if you just say, take a bucket of water and if you throw the same ball into the bucket of water, what happens to the ball? The ball goes inside. We are considering the ball is heavier. Correct? Yeah. So that is called what? Refraction. Okay. So when there is refraction, there is change in the path. But when there is reflection, there is again change in the path, but it is just it is just bouncing back to the same medium. So now we got to know the difference. Now, reflection is mainly seen in a mirror. Correct? Yes or no?
Yes,
Yes.
ma'am.
Mainly it is seen in mirror, or you can see reflect. Okay. And we are able to see things around us is also because of reflection only, right?
Yes, ma'am.
The light is falling on me, it is getting reflected to the camera, and through the camera you people are able to see me. Otherwise, will you be able to see me?
No.
You would not be able to see, correct? Same thing with you also. The light is falling on you, it is getting reflected, and that reflected light is captured from the camera, and I am looking at you people. Correct? So this is reflection. So now for reflection, we mainly need, so major reflection where it takes place in a mirror. Now, where and all have you seen a mirror? In what all situations you have seen mirrors, you have to tell me. So we will split this chapter into two parts. One is only reflection part, and next we will study refraction part. So first we will only study about reflection. So reflection through mirrors we are going to see. Now you have to tell me what all situations, where and all you have seen the mirrors. Tell me.
In cars, in houses,
In cars, in hotels, okay.
In salon.
Salon, very good. Where else? At home you don't have a mirror. Srishti is sitting just in front of the mirror actually. I mean, the mirror is behind her. Smriti, sorry, not Srishti. Okay, now the question is, the mirrors where you told in car, at home, or in the salon, are all of them same type?
No, ma'am.
Are they
No.
same type
No,
of
ma'am.
mirrors? They are different. Is it? Okay, one more place you have seen a mirror is in the parking place, parking of apartments or parking of any big mall is there in the parking lot. You might have seen this type of mirror placed during the crossing somewhere. Have you noticed that orange frame will be there on that and one mirror will be placed?
Yes,
Have you
ma'am.
noticed? That is also a mirror. So that is a different type of mirror now. So now we are going to see spherical mirrors. The mirror what we have at home, that is a plane mirror. Okay. Or if you see in any vehicle, the rear view mirror what you have, that is a different type of mirror. That is a spherical mirror. The rear view mirror is a spherical mirror actually. Okay. Especially in two-wheeler, you can make out actually. The rear view mirrors what you have in a two-wheeler, on that something will be written. What is that?
This image will appear closer than usual.
Because it is a spherical mirror and spherical mirrors have different qualities. So now what is the different quality? What is the spherical mirror? Let us understand this. First, let us understand what is a spherical mirror. Then we will understand what are the properties of this spherical mirror. Okay. Now I want you to imagine few things. First, imagine a ball of glass. Okay. There is a glass ball. This glass ball, 1 second. Give me 1 minute. There should Yes, now consider this is a ball made out of glass. Okay. What I will do is I will cut this. So if I cut this, I get two different parts, right? Now what I will do is to this part, here I will put a silver coating inside. So this will act like a mirror. Okay. And for this one, this side I will put the silver coating. So inside part will act as a mirror for me. Right? Understood? Everyone? Yes, my daughter's toy. She's put clay inside this Play-Doh. Understood this, right? Concept?
Yes, ma'am.
Everyone, right? Huh. Okay, now. So now, if it is a complete thing, so we can call it a sphere.
Yes, ma'am.
So
Yes, ma'am.
the mirror which is formed of a sphere is called a spherical mirror. So how did we get the mirror? What I did, I just cut this ball into two parts and I got two mirrors. I have to put simple thing. You take a plain glass, you put silver coating, then it becomes a mirror. Okay. So here what I did, I cut a sphere of glass. Okay. And then I put silver coating and I got two mirrors. So the mirrors which is formed by a spherical surface is called a spherical mirror. Understood what is a spherical mirror? So in this
Yes,
spherical mirror, we have to understand few things. See, a spherical mirror is a section of a sphere. It can be concave or convex. Now, what is this concave and convex? Let us understand. Now, two parts I have, right? So I tell, so now first part I have taken. To this first part, what I did, inner side I put the silver coating and this outer surface is acting as a mirror, I said. Correct? So this is the reflective surface and this part is the silver coating, right? This is the reflective surface and this side is the silver coating. So this is like a wax. So you call this mirror as convex mirror. Understood what is a convex mirror? Okay.
Yes, ma'am.
Next, a concave mirror, if you say, it is exactly the opposite. Can anybody explain now? What is a concave mirror then?
It'll be
Convex
like
you understood. Convex you
the
understood?
opposite.
Huh. Concave
It
is
is
opposite to
bulged
this.
in.
Uh-huh.
The mirror is bulged inwards.
So the other part I had, this part what I did, I put the silver coating to the outer surface and the inner surface is acting as the mirror. This is like a cave. So this is a concave mirror. Understood?
Yes, ma'am.
Yeah. Now we got to know the two different types of spherical mirrors. One is concave and convex, right? Now, there are few other things which we have to understand. Now, if I have a sphere like this, do I have a center for this sphere? Where do I get the center? The geometrical center. Simple thing. If I write a circle and I say, what is this called? If this is the radius, this point is called the center, correct?
Yes, ma'am.
So in the same way for sphere also, for solids also, you have a center. The center is somewhere here. Inside it is. Correct? Now, if I cut this sphere into two parts, the center will be still the same for the sphere, right? So that center is called center of curvature. Understood? What is that called? Center of curvature. So that is what is this center of curvature. Then next. So if you have a center, now can you tell me what is the radius? How do you define radius?
A point starting from the center of the circle to the circumference.
Yes. Point or line?
A line, sorry.
Yeah. The line which is between center of curvature and the surface or circumference, that is called what? Radius. So we know what is the center of curvature. So from this center of curvature till the circumference, if you draw a line, then that becomes radius of curvature. Okay. What is center of curvature we got to know. What is radius of curvature we got to know. Right?
Yes.
Okay. And whenever we draw a concave or a convex mirror like this, concave or convex, any mirror when we draw, we usually first draw one imaginary line like this, which is passing through the center of curvature. And that line is called principal axis. So you can say it is the line passing through the center of curvature. Is called what? Principal axis. Got it? So these are the few terms we got to know now. Now, what are the formation of the image? How is the image formed in a concave mirror and a convex mirror? We are going to study. Okay. First, we will only take concave. Next, we will understand convex. Now, so image formation in concave mirror. So this is very much important. They will ask you to draw these diagrams. These are called ray diagrams, and they will ask you to draw these ray diagrams. Each ray diagram will be for 2 marks. Okay. So they are very much important. You have to practice. If you just see or read, you will not get it. You have to write and practice, because all look like same. All look the same. So you have to write and practice. Now you will understand. It will be very easy. But then when it is asked in the exam at the end of the year, everything will go. You'll be confused which one to write. So I have done it this way. Remember, let us remember it like this. Position of the object, position of image, and property of the image. Okay. Now first let us understand few more things. We got to know what is principal axis, what is center of curvature, what is radius of curvature, correct? Now one more thing we have to understand, what do you mean by focus or focal point? I think it should be here somewhere. 1 second. 1 minute. Wait, children. Yeah, make it less. Okay, so these are the terms which we have seen. Sorry, this should be a terms related to mirror, not lens. Okay, make it mirror. So one is center of curvature. So center of curvature is the center of the sphere whose part is the mirror surface. A mirror surface, that is called what? Center of curvature. This can be the statement what you can write. Next is radius of curvature. So for the radius of curvature also, here wherever lens is there, you have to make it mirror. Okay. Then what is principal axis? It is the line joining the centers of the curvature to the circumference. Next, what do you mean by focal length? Focal length, or it is also called focus. It is the distance of focus from the central, from the optical center. So now what is optical center? Optical center is nothing but center of curvature. Okay. So that is called focus. Now, so focus is denoted by letter F. Center of curvature is denoted by the letter C. Okay. And principal axis, and then you have one more point called, this point is called pole. So now what is this pole? Pole is denoted by P. Pole is the center of the mirror. Center of the mirror, when I say midpoint of the mirror, you can say, not center of the mirror. Use it, write it as midpoint of the mirror. So when I say midpoint of the mirror, now this is the mirror, right? In this mirror, which is the midpoint? So this will be the midpoint. Correct? Got it? For this surface, midpoint is here. Understood? That is called what? Pole. So pole is the midpoint of the mirror, whether it is convex or concave, anything. For both of them, pole is nothing but it is the midpoint of the mirror surface. Got it? So what all terms did we learn? Center of curvature, radius of curvature, principal axis, focus or focal point, and pole. Okay. Now, when we are looking at the image formation, we have to see whether the object is placed, when we keep the object at different positions. When we are keeping the object at different positions, the image will be formed in a different position. See here, in this GIF video, you can understand. The white arrow, what it is there, that is the object. The yellow arrow which comes, it is the image. Okay. So now tell me first thing, whether this is a concave mirror or a convex mirror in the video.
Concave.
It's a concave mirror, correct?
Concave.
Yes. So now see here, when the arrow was very far, the image was somewhere here. When the object is far, the image was somewhere here. So as the object is going closer to the mirror, the image is going far away from the mirror, correct? And at some position, when the object is very close to the mirror, the object will be behind the mirror. See, when the object is here, the image is here, correct? Behind the mirror, right? So these things we are going to understand in a ray diagram. So now, what is the first position for the object? The position is kept at infinity. So when we say infinity, very far from the mirror, very far. Okay. When the object is placed very far from the mirror, what happens to the image? The image will be formed at the focal point or the focus. Focus, we write it as focus or focal point. Okay. When the object is placed very far, that is, we consider that distance as infinity, the image will be formed at focus. And what will be the nature of the image? Nature of the image is the image will be highly diminished. Diminished means the height and size of the image will be reduced. Mainly we are taking the height because we are representing it using arrow mark. So we will only consider the height. Okay. The height will be diminished. Diminished means it will be reduced. Got it? And it is a real and inverted image. So now what do you mean by real image and virtual image? We have to understand. Okay. The image which can be captured on a screen, that is called real image. Okay. What is a real image? The image which can be captured on a screen. It is called real image. Okay. Exactly the opposite is virtual image. Then what is virtual image? Can you define?
Images which cannot be captured on a screen.
Correct. The image which cannot be captured on a screen is called a virtual image. Now, the mirror what we have at home, that is called a plane mirror. Okay. In that plane mirror, do you get a real image or a virtual image?
Virtual.
Yes, we cannot capture that image on the screen, correct? So it is a virtual image. Okay. So here what is happening? See here, the light falls on the mirror from infinity and it gets reflected. And they meet at a point. So when you're writing the ray diagram, what you have to do, children, is one is the principal axis you will write. This one, principal axis. And for infinity, you just take two lines like this and reflect it. Don't mark the point F before only. What you have to do, I'll tell you how to draw this. Okay. I'll do a rough diagram. You have to use your pencil and scale for this. Without scale, you should not draw this ray diagram. Okay. You have the mirror. Then you will draw the principal axis. So this is the pole. This is the principal axis. Now for infinity, you just take two lines, like two parallel lines you take, which is falling on the mirror. Then do the reflection and it should meet at a point. Wherever it meets, that position you mark the image. And the image should be inverted. That is the nature of the image. The image will be inverted. It is diminished and real. And this point you call F. Okay. Understood this? How to draw? This is for infinity. Next, what we will do, we will bring the object little closer to the mirror. We are bringing closer to the mirror. But then it is still behind the behind the center of curvature. So if C is here, center of curvature, then we are placing the object here behind it, beyond it. Now see, again, we are taking two positions. One light parallel to the principal axis. And one ray is principal axis. One ray which is passing through the center of curvature. See, like this. I'll again draw a rough diagram and show you. This is the principal axis. Now this is our object. So one is taken parallel to the principal axis and the other line should be taken passing through the center of curvature. Okay. And the line which passes through the center of curvature will reflect back in the same path. Okay. The line which is passing through the center of curvature, this line, it will reflect back. So for reflection, let me take a different color pen. So this line has passed through the center of curvature, so it will go back in the same path. So arrow mark is put like this. Now this line which was parallel to the principal axis, draw that line in such a way that it cuts this line. So here they are meeting. So this will be the position of your image. Okay. And what after writing all this, you put the naming. So this will be F. This is C. So it is between C and F. Understood?
Ma'am, I have a doubt.
Yes, dear. Tell me.
Ma'am, when we draw these ray diagrams, ma'am, the focus should be in the middle of center of curvature and pole, right, ma'am?
Yeah. You don't
So,
measure and write. Just don't measure and write. No need to do the
ma'am,
measurement when
it
you're writing.
is automatic.
It will come. See, I just drew a rough diagram here. It was not using a scale. Then also I got it exactly the same.
Okay.
And the value of radius of curvature will be, radius of curvature is R. The value of that will be 2 times of F. Hey. Okay, R will be always 2 times of F. Got it? So you don't have to measure and write. You can just write like this. But use your scale and pencil. And to get a proper shape for this mirror, use a protractor or a compass, better compass. So just take a compass, okay? Draw a semicircle. So where you will keep, see, you will keep your compass here and draw a semicircle with some radius like this. So this will be your center of curvature. Correct? This will be the center of curvature. Then passing through this line, through this point only, draw the principal axis. Draw principal axis passing through this. This will be principal axis. So obviously it will go through the pole only, correct? When you have drawn the semicircle using a compass, so it will go properly. Then beyond C means don't go too far from C. Somewhere here you place your object. This is your object. So one line parallel to the principal axis and one line passing through the center of curvature. Then reflecting line through the center of curvature will be same. It will retrace. And when it is the parallel line which is parallel to the principal axis, it wherever it cuts this second line, so there only you draw your image. And then after your image is written, you just mark this point as F. Got it? Yeah.
Yes,
So they will ask you the question like this. Draw a ray diagram for a concave mirror, when the object is placed at C or beyond C or between F and P, and state the nature of image. You have to state the nature of the image, nature and position of the image. So first you just write it this way, 3 points. Position of the object, whatever is given beyond C. Image, position of the image, where is the image formed? Between C and F. And then what is the property of the image? Image is diminished. See, obviously it will be diminished. Correct? It is diminished. And what is the image you got? One more, inverted, and you can capture it on a screen, therefore it is real. Got it? Understood? It is diminished. See, the height is reduced, so it is diminished, and it is inverted. The object was like this. We got an inverted image here. So it is inverted, and then it is a real image.
Ma'am, in the second one, center of curvature doesn't look in the center, right? It's more towards the left.
Huh? Where? This one?
Like, yeah, the center of curvature doesn't look in
No.
the center.
It is at the center. These diagrams I didn't draw.
Yeah,
These
yeah.
diagrams are taken from Google. You're trying to measure it?
I don't know, I don't know. I think it's in the center, but it doesn't look like it's in the
Okay,
center.
fine, no problem. But then I told you what is the technique to be done. Like, how do you do it? What technique you have to use? Okay? If you do it that way, then it will look properly. Try it out.
Okay, ma'am.
Okay, so for today, only 2 positions are enough. 2 more positions are there tomorrow. If I teach you all the 4 positions at once, you'll get confused. So first one we saw when the object is placed at infinity, and the second one is when the object is placed beyond C. Next we will see when it is placed at C. Here we will place the object. Then we will bring the object here. Then we will bring the object here. So 3 more positions are there. At C, between C and F, and between F and P. Okay? For all the positions, it will be inverted only, and it will be real, except for the last one. For the last position, it will become a virtual image and erect and enlarged. Okay? Now I have few questions for you. First question is, you have a plane mirror? You have seen a plane mirror? Yes.
Yes, ma'am.
Now, what is the nature and position, or just tell me what are the properties of the image in a plane mirror? And what will be the position of the image also in a plane mirror?
Ma'am, it will be real and inverted.
Is it real?
So,
Plane
yeah.
mirror? Real means you can capture it on a screen. Can you capture
Yes,
the screen?
virtual. No.
It's virtual. So it is behind the mirror what we are getting.
Yes, sir. And the size remains same.
Okay, the size remains same. Then,
Ma'am, and the left appears to be right and right appears to be left.
yes, that we call it as lateral shifting.
Yeah, lateral inversion, right?
Lateral inversion or lateral shift, we say.
Okay.
Laterally inverted. We will be laterally inverted. Left appears
And
to
the
be right.
And the position of the image is the same distance as the object from the mirror.
Correct. The position of the image is same as the object from the mirror. Yes, that means if you go very close to the mirror, then your image is also coming close to the mirror. Correct? If you go far from the mirror, the image is also going far from the mirror. It will be at same position. So what will be the nature? So position we got to know, it is a same position as the object, and the nature is it is of same size, it is a virtual image, and is it erect or inverted?
Direct.
Erect only, for sure. If you're standing straight, will it not the image be upside down?
No, it's straight only.
Straight only, okay. Okay, fine. So it is erect, okay, and it is a virtual image, not a real image. Okay, let us recall what all we studied today. So first thing is, we got to know what do you mean by a spherical mirror, correct? And in the spherical mirror, we saw that there are two different types of spherical mirrors, right? Which are they? Concave and convex. And today, while having dinner, use your concave and convex mirrors. Every day you're using it.
Spoon, right?
Yeah. Look into the spoon, look at the image in your spoon and tell me. I told you now, in a concave mirror, we get an inverted image. Just try it out. Do you get inverted or not?
Yes.
Take a little bigger spoon and just look into your face. Will it be inverted or straight? Okay, now spoon. When we say spoon, I don't have a spoon here nearby. No, I don't have a spoon. Fine. When I say spoon, which side of the spoon is concave and which side is convex? We'll take it this way: the side where we eat and the side opposite to that.
The side where we eat is a concave.
It's a concave mirror. The opposite to that is convex mirror. Okay, so now in the concave mirror, we have told that the image is inverted. So you have to look into yourself. When you're having your dinner, obviously you'll be using your spoons. Just see, look at your image and find out whether you're inverted or erect. Try this. Try this. Move the spoon far in front, to and fro. Okay? Just do it to and fro, you will get it. Wait, dear. Try this. What will happen? And in the next class, you have to tell me. Yeah, and next class, I'll be taking mathematics, children. We will start mathematics also. And to start mathematics, I want you people to tell me one thing. Which chapter have they started in school? Let me start the same chapter for you.
Real numbers.
Real numbers. What about others? Daksha and Harshit, I think your people are from the same school.
Yes, ma'am.
Yes. And what about the other two? Shreya?
For us, started real numbers.
Real numbers only. Okay, then majority wins. We'll go with real numbers. So we will also start real numbers here. Okay. So you have already heard in school already real numbers are done. Now I'll be asking you more and more questions on real numbers. So we will finish this chapter fast and we'll go to the next chapter.
Ma'am, they have also deleted in real numbers.
I don't think so.
The
So early.
Euclid's division.
So early is
Euclid's
it related?
Yes, ma'am.
Okay, I'll see what is it. I'll
Yeah,
just
sure.
ask and do whatever is required. Otherwise, we'll see whether it is. Even I don't know. I don't have a confirmation about it is deleted
Ma'am,
or
it's
not.
there in CBSE website, the
Okay,
official website.
I'll just go through it and then see
Yeah,
what will
sure.
be done. Okay. Okay then. So today's work I have given. One is looking at your face in the spoon, and the other one is going through the real numbers chapter. Probably the class will be given tomorrow, maths class. So in a week, full day, I mean, in a week completely, if I have class every day, one class, then we will do alternate days. One day science and one day physics and one day maths. Okay, we'll do it that way. So that both the subjects are in balance. Or I might take maths more and physics less, because physics only 4 chapters, maths all the chapters have to cover. We'll do it that way. Okay. Yes. Thank you, children. Bye, everyone. Good night.
Thank you,
Thank you,
ma'am.
ma'am.
Thank you, ma'am.